You know, we hear the term Construction 4.0 thrown around all the time, right? But a lot of the time, it just feels like another industry buzzword. So today, we're going to cut through all that noise. We're getting past the theory to see what this revolution actually looks like on real, live job sites around the globe. So let's get into it.
This is really the big question we're trying to answer here. Not some vague, futuristic idea, but what does it look like on the ground right now? We're on the hunt for practical, real-world examples of how technology is solving old-school problems today.
So here's our game plan. First, a quick look at what Construction 4.0 really is. Then we're taking a trip. We're stopping in Brazil, the UK, and the USA to see how they're tackling completely different challenges with tech. And at the end, we'll pull it all together and figure out what it means for you.
All right, let's set the stage. What we're talking about here is a huge shift in how we build. It's all about creating this constant conversation, this feedback loop between the digital model on a computer and the physical work happening out on site.
Now, what's really important to get here is that Construction 4.0, it's not a single piece of software you can buy. It's more of a framework, a new way of thinking. Imagine it's where things like prefabrication, smart sensors, and powerful digital tools like BIM, that's Building Information Modeling, all come together. The big idea is pretty simple, actually. You create a perfect digital twin of your project, use that to plan everything, and then, this is the cool part, you take data from the real world and feed it back into the model. It's this amazing, continuous loop of improvement.
Okay, first stop, Brazil. And here we're looking at a problem that anyone who's ever been on a job site will recognize. How do you make a repetitive, heavy job more efficient and, most importantly, a whole lot safer? And yeah, this picture, it says it all. You've got these massive steel formwork panels being muscled into place. It's complicated, it's slow, and honestly, there's a huge potential for things to go wrong. You're looking at delays, or even worse, accidents. It's basically organized chaos. So, how do you fix that chaos? Well, you choreograph it. It's like a digital dress rehearsal. Using BIM, the team first built a perfect 3D model of every single panel. Then they figured out the absolute best, most efficient sequence to install them. They even created a 4D simulation, that's the 3D model plus time, so the entire crew could watch a video of exactly how the job was going to unfold before they even picked up a tool. And boom, look at the result. That digital rehearsal translates directly into a calm, predictable, and way safer process on the ground. Everybody knows exactly which piece goes where and when. All that chaos from the first picture, it's gone, replaced by a clear, repeatable workflow. That saves a ton of time and seriously reduces risk. All right, for our next stop, let's head over to the UK. Here, we're tackling a much bigger problem, a societal one, really. The housing affordability crisis. This is about more than just making a job site run better. It's about changing who gets to build a home in the first place.
This quote from Alistair Parvin it hits hard. He's pointing out that good design and quality construction have become luxury items, totally out of reach for most people. The WikiHouse project was born out of that frustration. It asks a simple question. What if we could give the tools to build back to the people?
And their solution is just brilliant. WikiHouse is an open-source library of 3D building models. That means anyone can download the files, take them to a local workshop with a CNC machine, which is basically a computer-guided cutting robot, and have all the parts of their house cut out perfectly from something like plywood. It is literally like building with a giant, high-tech Lego set.
Okay, that's a cool idea, but what's the bottom line? Well, the impact on cost is just staggering. Look at this number. This project, the Wiki Farmhouse, came in at about £800 per square meter. The typical cost for a self-build in the UK? It's more than double that. This isn't just a small saving, it's an absolute game changer. So let's actually watch one of these come together. In this first step, you can see all the precisely cut plywood pieces, or cassettes, arriving on site. Because they fit together perfectly, like a puzzle, a really small team with not a lot of specialized training can start putting the main frame together incredibly fast.
And just like that, the main structure's up. Here, they're wrapping it in a waterproof membrane, getting the whole thing sealed from the weather. The speed here is just unreal, and it's all because the hard work, the thinking, was done in the digital design phase.
And finally, the roof goes on, the cladding goes on, and you've gone from a bunch of digital files to a finished house. The implications are massive. This points to a future where anyone, any community, could respond to their own housing needs, faster, cheaper, and with so much more control.
All right, for our last case study, let's fly over to the USA.
Now the puzzle here is different again. This is all about trying to manage the incredible complexity, the risk, and just the sheer mountain of data that comes with a big, modern construction project.
So at Oracle's Innovation Lab, they're building what they call a smart job site. Workers have wearable sensors, the Internet of Things, that can actually warn them if they walk into a dangerous area. Drones and cameras are constantly scanning the site. It's called reality capture, and creating a perfect up-to-the-minute digital copy of everything. And then all of that data gets plugged right back into the project schedule, creating a live 4D model of what's actually happening versus the plan.
And this image gives you a feel for it. It's a test bed, really, where everything is being watched and measured. The whole point is to stop being reactive, fixing problems after they happen, and start being proactive, preventing them before they even start. I mean, think about the long-term impact on things like insurance costs or just being able to guarantee a project schedule. It's huge.
So, okay, we've been to Brazil, the UK, the US. We've seen 3 totally different problems get solved. So what's the common thread here? Let's boil this all down into one simple, practical takeaway.
This table lays it all out perfectly. In Brazil, the challenge was efficiency and safety, and the tool was 4D planning with BIM. In the UK, the challenge was cost, and the tool was open-source digital fabrication. In the USA, it was risk and complexity, and the tools were IoT sensors and reality capture. See the pattern? It's never about tech for tech's sake. It's always about a specific tool being used to solve a specific problem.
And that, right there, is the most important thing to remember. Construction 4.0 isn't some magic product you buy off the shelf. It's a toolbox. It's about looking at your project, identifying your biggest headache, your biggest bottleneck, and then finding the right tool in that box, whether it's BIM or drones or something else entirely, to fix that problem.
So I'll just leave you with this one question to think about. What is the single biggest problem on your job site? The thing that causes the most delays, the most risk, the most cost? Because as we've just seen, chances are there's a tool in the Construction 4.0 toolbox that's being designed to solve it. The future isn't about adopting everything all at once. It's about starting with one problem and finding one smart solution.